Have you ever wondered what really happens behind the scenes when two products compete for the same customers? Why one product dominates while the other slowly fades away, even when both start almost equal? In this video, we are going to simulate exactly that. A market competition between two products, let's call them product A and product B, using agent-based modeling combined with system dynamics in AnyLogic PLE. We will model advertisements, word of mouth, product quality, and initial stocks, the replenishment of stocks, and we will see that how these things drive customer decisions and how poor supply chain performance can completely change the outcome even for a better product. So the first thing is the disclaimer about the videos and the software used. Before you begin, let's talk about the ABM tutorial that we have done before. So you if you are new to this channel, I would advise you to watch those tutorials from part 1 to 9 before starting this session. The link of those tutorials is mentioned in the description. The simulation done in this video, it builds directly on the concepts and the models developed in those parts, and because we are building up on some foundation that we have already covered, so this is going to be a fast-based tutorial. The prior concepts of ABM basics are essential to keep up. And as discussed before, the simulation will not be just simple ABM. It will be a multi-method modeling and simulation. But don't worry, it will be fun. Okay, now let's discuss the key parameters which affect a market competition. We discussed in our previous videos that product adoption, it is affected by advertisements, the word of mouth, the discard time, which indirectly suggests the quality of the product. So we model customers as agents, and these agents, they transition through states from based on the advertisements. Some of them would want A and some of them would want B, and they would purchase it, but due to some delivery times and delays, they might change their decision to buy that product, and they can enter into a new state which we call as buy anything. So in this setting, we are going to discuss two scenarios. So these key parameters, now I am going to discuss them in detail, so don't worry. Okay, scenario 1. In the first scenario, we are going to discuss a competition between two products A and B, that the suppliers have the equal stocks of these products, and in this the first scenario, there will be no restocking. So there will be a stock which would be consumed, and there will be no restocking, and we will assume that advertisement of A is better than B, and there will be some parameters which will be equal for both A and B. For instance, the word of mouth, the adoption fraction, the contact rate, and the give up waiting time. So if you're not understanding any term here, let's say give up waiting is something new, so we will discuss it in the next slide, so don't worry. But the rest, the word of mouth, adoption fraction, contact rate, add A, add B, we have already discussed them in detail in our last tutorial, which comprised of 9 parts. So if you haven't watched them, again I'm telling you, go and watch them, go watch these parts and then come here again. Okay, and we will see that how the goal would be to see how parameters lead to different outcomes due to better marketing, because here the only thing that is the difference between the two products A and B is better marketing. So initially we have a population of potential users, 5,000 customers. So you might be wondering that why I always use this 5,000 number here. So why this is always 5,000. So the reason being that because we are using AnyLogic PLE, and AnyLogic PLE has some limited capabilities, so that's why we we use 5,000 agents, because the PLE, the personal learning edition, it is limited to the 5,000 products, 5,000 agents, sorry. So when these potential users, when they come across advertisements, let's say that the advertisement, that the ad effectiveness of the A is 0.015 and for B it is 0.008. And what does that actually mean? We have already discussed this. That means that if 5,000 agents watch these advertisements, that then 0.015 of these 5,000 will be kind of affected by, moved by these advertisements, and with and they will become, they will move to a new state where they would want A or want B. And they will, the agents who are in want A, they will buy A if the stock is available, and once they buy A, and similarly they can, the want B, the agents in want B state, they would want B, and they would purchase B if the stock is greater than 0, and once they have purchased it, they will become user A or user B. And once they are users and they are happy with the quality of the product, they would contact other agents, and they would try to influence them that, yeah, yes, go for product A or product B. So we model this thing by word of mouth. So we have model word of mouth as word of mouth A and word of mouth B. So word of mouth A, we have modeled it by uniform, by adoption fraction. This is uniform 0.1 to 0.25. So that means that when the user A or user B, they contacts the agents in the population, uniformly distributed uh, fraction, let's say point from between 0.1 to 0.25 of these agents will be influenced by the users, by the already users. And when, and the agents who will be influenced, they would want A or B. And the product has a life of 6 weeks, and after 6 weeks the product will be discarded, both A and B. And there is like market stock available of A and B of 42,000 items each, and this stock is limited. And I discussed earlier in that in scenario 1 we are not going to replenish the stock, so this is a fixed stock. So the things are not always pretty, and there might be some delays in delivery of product A or product B. So when, and I have modeled that time as 0.3 to 0.8, uniformly distributed or randomly distributed between zero point 0.3 to 0.8 days. So when this happens, the want A or want B, they move to another state which we call it as want anything. Now once they are in want anything, they can either buy B or they can buy A, depending on the only one condition, and that condition is that the stock of that thing is available, it's greater than 0. So as discussed earlier, the replenishment of the stock is not an option here, so we are not going to use it in this first scenario. So there are some important points here. So the most of the model that we will follow, it will follow the steps discussed in the previous tutorials, and some would be new. For instance, we will be using stocks A and B. They come from the system dynamics library, and that's why I said that it's going to be a multi method approach. We are going to combine agent based modeling with system dynamics. We will define 4 variables and 1 event in the main diagram, and the first the variables are current user A and the current user B. Basically, we want to track of how many people are using product A or B at a given moment in the simulation. And then we have another two variables, the cumulative user A and the cumulative user B. Basically they will count the total number of people who have ever used A or B at any point during the whole simulation, even if they switch or they stop using it. So four variables, the first two are the current user A and user B, current user B, for obtaining the information that at any given moment of time how many people are using the product, and then we will also do the cumulative of these users. And then we will define an event, we will call it as track adoptions. Basically the purpose of all this thing is that we want to know that how many people or how many agents have used product A or product B in the entire simulation time. So for to track that adoption, we will define an event track adoptions, which will be triggered by the timeout cyclic mode, and it will have a 1 day recurrence. 1 day recurrence. Okay. Now in the entry in the event action for this event, we will type this code. So it's a very simple code. I'll just explain it here. And what we are doing here is that first we figure out how many people they have started using the product, started using A today. We count all current users of A, and then we are going to from subtract them sorry, not here, we are going to subtract them from the current users we had yesterday. This difference, the difference between the consumers who are in user A state and the current user A state, it will give us it will be stored in this variable new user A. So basically this different, it tells us who is new. So current user A, it serves as a baseline to calculate new user A. Similarly, we are going to calculate the new users of B by counting today's users and subtracting yesterday's current user B. And again we are going to use current user B to find new users B. So once we know the users, the new users, we are going to do a cumulative. So this cumulative user A and plus equal to max is this is basically what it is doing is it is adding it updates the cumulative user A, and we want to make sure that it does not go down, so we are using the max formula. The logic is basically that, let's say some agents are using product B, the one, let's say on day one or any day, and the next day if that number drops, then the new users will be a negative term, and we don't want to add that negative term, so we want to add only positive terms. That's why what we have done here, we are using the cumulative user A or B. If you can have a look at it, like look here, they are either taking the zero value or any positive value. Then we have the final thing, the current user A, and what we are doing is here that finally we are updating current users A and B, and we are updating it with the latest count of A users or B users. So why? Because to the next day, tomorrow, we can calculate the next day's new users. So we are doing the same thing with the B as well here, and just trying to create an analogy here, that it is like, the current user is who is shopping right now. If you compare it to a supermarket, current user is who is shopping now. Cumulative users is a total who have ever visited, and this code tracks daily new shoppers. So Hopefully it is clear to you. So we will use this code to track the new users in our program. Okay, so uh, let's uh, let's go to any logic and see how this is actually done.